We are back. Episode 5 of the Boiler Wild
Riverside
podcast.
FM.
My name is Eric Johnson, and on this podcast, we talk about boiler industry topics as well as personal development, as I believe personal development is a huge factor in our lives and in our careers, in what we can achieve and get as humans out of life. Today was a great day. It was today, Monday, starting off the week. July 7th, 2025. I am living in Florida right now, and it's hot. It is 90-some degrees every single day. Sun is out, and it is a great day every day. Try to make it a great day every day, but some days it can be a little warm. Do have a trip on Wednesday, so flying out of state. So that'll be good to get out of Florida, see something different, and that will be a test to see if I can record a podcast through all those days, being on a trip, being out of my normal schedule, and I will make it happen though. I'm dedicated to the mission of a podcast every day. So I just have to quick sidebar, social media, Instagram. I get on Instagram every so often, every day, let's be honest, every day. And I mostly scroll, and I will try to limit the scrolling, but there is one account I got to shout out. There's a lot of boiler accounts that, they post corporate stuff, boring stuff. A lot of companies post boring stuff. It's hard to, if you try to post bland stuff, it just never comes out. And if you try to be like corporate professional, it just doesn't show up well on social media, and it's boring, gets no engagement, and most people think, well, that's just what companies do. Well, I just watched a couple videos from this account, Utah Transportation. It's just the Utah Department of Transportation, but their account is Utah Transportation. But they have an amazing social media team, and they make the Department of Transportation fun. They make fun videos about closing roads and fixing bridges and tearing down bridges and replacing bridges and all this stuff. And it's informative, but it's also fun. And I follow the account, and I don't even live in Utah. And thousands of people follow the account, and they don't even live in Utah. But you almost get more eyes on information that you need to put out to the public by making fun videos like that. So if you're looking for something different, go look up the Instagram account Utah Transportation and just see how a government agency can make something fun out of fixing roads and plowing snow and what seemingly is boring stuff to most people. And instead of, posting a black photo with white text, hey, whatever highway is going to be closed on the weekend. Everybody scrolls past that. But then they make a fun video with like a dog or something that's like very meme style that's just ridiculous. And then people watch it and they go, oh, yes, reminder that this highway is closed. Like, this is what you need to know. And then they put up the maps for the reroutes and all that stuff. Like, it's just very creative and very well done. And it's something different beyond what most corporations and like professional accounts are posting, which is just bland stuff that nobody wants to see. Anyways, getting back into boilers, this is going to be the first kind of technical boiler episode. Been kind of talking about personal development stuff. Previous episodes, a little bit background on me. I was a service technician, and I started CEO and founder of a boiler training company called Boilearn, Boilearn. That's Boiler and Learn, 2 words mashed together. It's made up. So if you type it into Google, I'll be the entire page of Google because it's a made up word. But look it up if you want to. Just help organizations, operators, tractors, train their people, in-person classes, online classes, more coming out. Stay tuned for that. Working on something. Stay tuned for that. But our topic today is boiler safety, and we're going to be talking about one particular safety incident that is probably the most notable and most used that I've seen. It's only the most notable probably because it has the most pictures available on the internet. The report on the internet is one of the few reports that I've seen of a boiler accident. And boiler accidents are never fun. If they do happen, hopefully nobody is injured, but many, many times somebody is injured or people die. And it's always something that can happen. But I've always told people, if you're uninformed, you can think boilers are extremely dangerous, and they can be if they are operated wrong. If you do everything correctly and make sure all the safeties are working correctly and do it by the book, boilers are very safe. We have ASME that has existed since like 1910, and ASME, which is the American Society of Mechanical Engineers, has spent a ton of time writing the boiler pressure and vessel code, which essentially sets the minimum standard for how a boiler should be built, and that makes boilers extremely safe. Now, if you go back 100 years, 150 years, boilers were blown up all the time because we had no standards and we didn't have like electronic controls that were as standard and as advanced as we have today. And I would venture to guess, I have no data on this, but I would venture to guess that every single boiler accident, there were multiple bad decisions before the accident that were intentionally made before the accident occurred. And we will see those bad decisions today. So the boiler accident that I'm talking about happened at a place called Dana Corporation in Paris, Tennessee on June 18th, 2007. The report came out July 2007. If you look up Dana, D-A-N-A Corporation, boiler explosion online, you'll be able to download this PDF of the report. And, you go into the photo search. The PDF has photos in it, but if you just pull up photos, there's also photos of the aftermath of the explosion. I'm just going to go through this PDF. It's very well done. The guy who did it, Marty Toth, he was the chief boiler inspector of Tennessee at the time. Actually just had breakfast with him last week or the week before that. Very knowledgeable person. And he helped or led the investigation for this boiler explosion. And there's a lot to learn from it, and let's get into it. So I'm going to read the synopsis. You can go back and read the whole PDF. It's not super long. It's only 23 pages, and a lot of those pages are just pictures. But the synopsis, about 1:50 p.m. on June 18th, 2007, Boiler 2, located at the Dana Corporation plant in Paris, Tennessee, exploded, causing extensive damages to the facility and surrounding area and seriously injuring one employee. The 2000-built Cleaver Brooks high-pressure fire tube boiler was operating concurrently with a second high-pressure boiler. Both boilers were online to handle the steam demand of plant operations. The investigation team considered many factors during the operation of the boilers at the time of the explosion, past and current maintenance, boiler attendance and operation logs, audible visual alarms, past inspections and findings, installation and condition of controls and safety devices, and witness accounts. It is determined that the probable cause of the accident was a sudden introduction of feed water to the boiler that at the time of the explosion was operating in a dry-fired state. Before the explosion, inoperative controls and safety devices allowed Boiler 2 to continue to fire even though water levels in the boiler were at a dangerously low point. The excessive, rapid expansion of pressure that was created due to the introduction of feed water to the overheating surfaces of the boiler exposed dynamic forces on the boiler furnace tube, causing it to collapse and subsequently explode the boiler. There are a number of factors that contributed to the accident. A lack of standard training and boiler operation procedures, inadequate boiler attendance and record keeping, inadequate and improper boiler maintenance, and inoperative and improper boiler controls and safety devices. So that's the synopsis. Essentially, the boiler exploded and the pressure vessel ruptured because the boiler was in a dry fire state. So when you have a high pressure steam boiler, you have two low water cutoffs. You have a primary low water cutoff and you have an auxiliary low water cutoff. And when both of those fail, the boiler has no idea that there's no water or that the water level is not in the proper position. And if the feed water controller to the boiler, which is normally part of the primary low water cutoff, but if the feed water controller to the boiler is not keeping up with the boiler, then the boiler water level is going to drop below the normal operating water level, which is going to be like 2 to 4 inches above the top of the top layer of tubes. In this case, it was a fire tube boiler. Like the synopsis said, it was a Cleaver Brooks high pressure fire tube boiler. It was the integral burner with its big dry back doors, probably the most famous boiler design out there. If people have seen a Cleaver Brooks boiler, it's probably this one. And it's probably the one you're thinking of in your mind as you listen to this. So anyways, when the water gets below the top of the tubes and the boiler is still firing, there's now no water to take the heat away from those tubes. The heat from the furnace, from the fire and the combustion gases going through the tubes, it starts heating up the tubes, and the tubes become like red as you heat up metal becomes red. You can explode the pressure vessel by re-adding water to the boiler. So the boiler water level drops to an unknown level that is dangerously low. The boiler is still firing because both low water cutoffs failed. And now a bunch of the metal inside the boiler is red hot because it doesn't have water to take away the heat from the combustion gases. And then when you re-add feed water, let's say it's 200 degrees feed water, doesn't really matter the temperature, but you re-add the feed water. That feed water hits that red hot steel and expands, I believe it's 1,600 times the volume. So if you can imagine like a cubic block of water and that expanding 1,600 times into steam. And that expansion is so rapid that the safety relief valves on the pressure vessel of the boiler can't relieve the amount of pressure increase and volume that is happening inside the boiler. And if it is enough volume, which it normally is, it will rupture the pressure vessel. And in this case, it collapsed the furnace, or some other people call it the Morrison tube, collapsed the Morrison tube and blew off the rear door and moved the entire boiler pressure vessel from where it was installed in the boiler room. It went through a brick wall and slid into the center of the manufacturing facility. Probably, it's over 100 feet from where the boiler was installed to where it ended up. The rear door, which is, 2,000, 3,000 pounds, full of refractory, it was facing the outside wall. So that went through a brick exterior wall of the building and ended up in a ditch on the road, which is, 500 feet at least from the pictures. So just think about all that weight. So we have to move a 30,000 pound boiler, whatever it is. I don't know the size of the boiler, but tens of thousands of pounds, probably 30 to 40,000 pounds. We got to move it 100 to 200 feet in one direction. And we're throwing a rear door, which is 2 to 3,000 pounds, somewhere around that. They're heavy. In the other direction, 2 to 500 feet. Just imagine the amount of energy that requires. That is what happens when you reintroduce water into a red hot boiler. If you aren't already aware, when you go into a boiler room and you have steam boilers, you're supposed to check the water level of each boiler as the first thing that you check. And if you cannot establish a water level, manually adding water to the boiler is not the correct thing to do. It will differ on, how the boiler's set up, whether it's a fire tube, water tube, but you need to secure the feed water. Adding more water is worse than making sure no more water goes in. If the boiler is already red hot on the inside, it's already too late. So you secure the feed water, so you shut off the valve, then you can shut off the pumps, and then you shut down the boiler at the burner switch. So now the boiler is cooling, and you make sure that no more water gets in so that you can't have that rapid expansion. You're going to want to shut off the gas. So you go to the inlet of your gas train, shut off the manual valve, and now you've secured that boiler. Obviously lock it out and then probably evacuate the area depending on, the situation. Every plant will be different. You probably have different procedures, but in that case, the boiler is unsafe if you cannot establish a water level and the boiler was firing. That is why it's so important to walk into a boiler room and establish the water level, look at the sight glasses, make sure the water is moving in the sight glass. If the water is steady, you should probably be suspective of that. Maybe blow down the water column if you can. And if the water level moves, it's a good water level. If you blow down that water column and that water level doesn't move in the sight glass, that sight glass is probably plugged and is just trapping water. So you should be suspective of that. Anyways, going back to this boiler explosion, how it kind of came about was the primary low water cutoff, which was a McDonnell Miller 150S, is a float low water cutoff, probably the most popular low water cutoff in the boiler industry. And it had broken and had some broken fins, yet they still were running the boiler with it. But what ended up happening is the boiler kept shutting down and having irregular low water cutoff issues. So somebody replaced the secondary low water cutoff to fix it. And that secondary low water cutoff was a Warwick style probe low water cutoff. The old style ones, they got like 2 transformers on the side. They're no longer made, but they took a low water cutoff and they took a similar one that looked identical to it, except it didn't have a manual reset, and they replaced it. Well, the other part that was not identical was contact 3 and 4. Instead of being normally open like they should on a normally low water cutoff, they were normally closed, and you could use this one for, say, a high water cutoff. So a high water cutoff, the contact on the relay is going to be normally closed. The boiler water level rises in the boiler, hits the high water probe, and then that contact would open and shut down the boiler. Well, in a auxiliary low water cutoff, it's going to be normally open, and the boiler water level is going to rise up, hit that auxiliary low water cutoff probe, and then close the contact. And water always has to be in contact with the auxiliary low water cutoff to keep that contact closed. But if the contact is normally closed, now you've defeated the relay, and the boiler is going to start without water touching that auxiliary low water cutoff. And the important part to learn from this is, one, you need to make sure you are making good decisions around boilers. There's no such thing as, it'll be fine for a couple hours. Let's just jump it out for a day. No, that's how you start making those bad decisions that lead to boiler explosions. And luckily, most boiler accidents end up with a close call. Most boiler accidents are not the case of the boiler ripping through a production facility. But that doesn't make melting a boiler or boiler damage and making bad decisions around boilers any less serious. We always want to make sure we're making good decisions around boilers. Accidents happen to everybody. You never prepare to have an accident. Nobody says, hey, we're going to have an accident today. No, accidents happen when you're not prepared for them. basically the definition of an accident. The second thing we want to pay attention to is if you are working on a boiler, you always have to pay attention to the parts that you are putting on the boiler. There are many boiler parts, especially relays, in this case low water cutoffs, that all look similar. You can have 10 relays that all look similar, and they will all have different contact functions, whether they're normally open, normally closed, wired for a manual reset, all this stuff from manufacturers. And if you look, all the model numbers will be different. But to the average person, if you just say, what's the difference between these two? And you're just like quickly looking at them, you're going to say they're the same part. They are not the same part. You also need to make sure that you are testing a safety control when you put it on a boiler. So when you put a low water cutoff on a boiler, you have to fill up the boiler and then test that low water cutoff properly. There's no such thing as, yeah, I put it on, yeah, it works, we're good to go, production needs to go. No, you need to test it. If the person installing this low water cutoff relay would have tested the relay, they would have found that it wouldn't work. But that also goes into the safety and training portion. If you are working on a boiler, you need to have proper training. You need to have some idea of what you're doing. Doing HVAC service or knowing how to work on a rooftop unit is way different than working on a high pressure steam boiler or even a low pressure steam boiler. Low pressure steam boilers, even if a boiler is only running at 5 psi, that is a lot of pressure that can come out of that boiler depending on the boiler size. Even a small boiler. You got to think about it. PSI is pounds per square inch. So if you have, let's say, a 5x5 area, 5 feet by 5 foot plate, so for every square inch of that boiler, you're going to have 5 psi of force. So I can't do mental math. This is going back to the earlier podcast of I am not an academic person, but you do 5x5, 5x5, and you just think about all that across a 5 foot area over a 5 foot area, and all that force is pushing on that plate of steel. That's why tube sheets on a boiler are 3/4 inches thick, 1 inch thick, because they have to withstand the amount of boiler pressure that is pushing over the entire area of that plate. You have stay rods inside of a fire tube boiler. Stay rods are essentially solid pieces of steel that either get bolted or welded between the tube sheets, or most often they are welded from the tube sheet and attached to the shell. And those stay rods support each side of the tube sheet so that the tube sheet does not bow out, and you can have larger diameter tube sheets and increased pressures inside the boiler. So let me read the most probable cause and we can wrap this up. And I would highly recommend, if you are around boilers, if you buy boilers, sell boilers, service boilers, if you're any kind of boiler industry, if you are in HVAC, anything, go look up Dana Corporation, Paris, Tennessee boiler accident. Download this PDF, read it, bring it to a service meeting, pass it around to other people. This is so well written, and there's so much to learn. And everybody says, know your history so that we can learn from it. We got to know our boiler history. This is a very unfortunate event that happened that was preventable. And other events have happened like this that sometimes are not as well documented. And don't think because you don't hear of boiler explosions and boilers melting and boiler accidents that they aren't happening. Most of the time today, when a boiler melts, it never makes the news. The company scraps it, gets it repaired, whatnot, and nobody's the wiser. And that does a disservice for the industry. Obviously, the company who owns the boiler doesn't want the bad PR. but it does a disservice for the rest of the industry. One, to realize boilers are still dangerous. Just because you think nothing can happen doesn't mean nothing will happen. Like I said, nobody prepares to have an accident. When you make bad decisions with boilers, eventually it's going to catch up with you. All right, let me read the most probable cause. This is just a couple paragraphs, and I'll let you get on with your day. It is determined that the most probable cause of this accident was the sudden introduction of feed water to the boiler that at the time of the explosion was operating in a dry-fired state. It is believed that when Mr. Evans was the boiler operator who was in the boiler room at the time when it exploded. I believe he got burned, but he did not die. It is believed that Mr. Evans discovered the boiler number 1 was in a low water condition. He proceeded to the vicinity of the boiler feed water pumps. It is believed that during this time, boiler 2 was at full fire. Not known to Mr. Evans, boiler 2 was operating in a low water condition. Feed water was then introduced back to the boilers. Whether this was due to maintenance actions or not of Mr. Evans has not been determined. From the evidence, it is deduced that the primary low water cutoff / pump controller float was wedged in the up position. This could have accounted for the boiler continuing to fire even though the boiler was experiencing a low water condition. Past experiences of high water in the boiler, which in turn led to the disconnection of the modulating feed water control of the feed water valve, could have led to the float becoming wedged. Since the modulating feed water bypass was opened halfway, the boiler water level would have fluctuated as the boiler fired, causing the primary low water cutoff to operate more as a control than as a safety device. This could account for the need to remove the required manual reset on the auxiliary low water cutoff. With the feed water bypass open, there could be no automatic control of the amount of feed water that enters the boiler. This could account for the high water conditions. On the other hand, if the boiler calls for more feed water than what is delivered through the open bypass, the boiler would subsequently go to a low water condition. Because of the manual reset, maintenance would be required to manually reset the boiler in the boiler room. By removing the relay with the manual reset with one that is automatic, once the boiler water level reaches a safe level, the boiler will begin to fire without any interaction from maintenance personnel. This is not allowed per code, reference CSD1 CW-40. Given that the auxiliary low water cutoff relay was replaced with the incorrect model, the primary low water cutoff did not respond and cut off the fuel supply of the boiler. The boiler continued to fire until the accident occurred. Without corroboration, it can only be speculated that operation of the boiler's feed water pumps had discontinued. Since the light bulb for the visual alarm for boiler 1 was blown, there was no way to know exactly how long boiler 2 was in dry fire. Based on the foregoing, it is concluded that the main cause of the boiler accident was improper maintenance and lack of operational procedures of the boilers. In addition, removal and replacement of critical controls and safety devices, along with the lack of proper training and qualified personnel, equally contributed to the occurrence of the accident. And then it goes into a bunch of recommendations, and there are a bunch of pictures. And that may have seemed to throw in some more details that I didn't talk about previously. That's also in the report. Scrolling through the report, it is 6 pages of text, and the rest are pictures. So it's very manageable. All the pictures are labeled on what they are. Like I said, this report is gold for training. This report is a reminder that bad things can happen to everybody, and we need to know that boilers are safe when operating safely, but we need to respect that. Just because something is written down in a code book doesn't mean the boiler is safe. We have to make sure the boiler is operating per best industry practices, manufacturer practices, so that we can stay on the safe side of the boiler operation instead of entering into dangerous territory. I think what catches a lot of companies and a lot of people is they make dangerous decisions and nothing happens. So they get reinforced with more dangerous decisions will lead to nothing else happening. So like an example of that would be, hey, if we jump out this auxiliary low water cutoff just to make the boiler run for the next shift till we can get one, it will be fine. So they jump out the secondary low water cutoff, boiler runs the whole shift, they eventually get a new part, they shut down the boiler, they change the auxiliary low water cutoff, they start the boiler again, and they think crisis averted, everybody's happy, we're good to go. Well, they were playing with fire because the primary low water cutoff was operating correctly, but there's no way to know that the primary low water cutoff would have not failed during that time. I learned from some of the best, and one guy I learned from, he would talk about with customers, and they're like, well, how do you know a safety control is going to fail? And he would ask the question, well, how do you know when a light bulb is going to fail? And you don't. You can come into a boiler and check all the safety controls and say, yep, everything is working correctly. And the next day, something can go wrong. There's no guarantee of like, hey, I checked all the safety controls. You're good for another 6 months of operation. Nothing will fail. Now, you should be able to see indications of failure or corrosion and all that stuff on a safety control, but there's no guarantee. The auxiliary low water cutoff, it is not an optional backup on a high pressure steam boiler. Just because there are 2 low water cutoffs on a boiler doesn't mean one is a backup and it's optional. There are 2 low water cutoffs because that is required, because we learned from our ancestors after they blew up thousands of boilers that we cannot rely on one low water cutoff. So then we made it mandatory on high pressure steam boilers to have 2 low water cutoffs. So both are mandatory. You cannot remove one from operation, jump it out, and say, oh, the boiler is still running safely. No, that is not allowed, and we are running on the dangerous side of boiler operation, making bad decisions, and that's what gets people hurt or killed. And unfortunately, too many people make bad decisions like that, and if somebody tells you to make a bad decision like that, you got to say no, and it doesn't matter if it costs you your job. You have to say no. You have to draw the line. That is why boiler safety is so important. If you jump out something and that boiler explodes, whoever told you to jump it out will never own it. They will point at you and say, I didn't tell you to do that. They will save themselves. So you have to save yourself. If you are trained to work on a boiler, you are responsible to tell others no. You cannot make decisions about the boiler that others direct that are unqualified to direct you. Some supervisor of a plant comes up and says, get this boiler running. I don't care what it needs to happen. And you say, hey, the boiler's unsafe. It cannot run because this, and this, and this. Here are some other options. We can get a rental trailer. We can get this. We can get that. And they say, nope, the boiler needs to run. It's not going to run. You are the stop. You have to stick up. The boiler's not going to stick up for itself. The boiler doesn't have feelings. The boiler can't decide for you or to run safe. The boiler is just an object. Safety controls are just an object. Yeah, you may have like semi-smart safety controls, but it's just electricity. They don't think. There's no thinking and action to those safety controls. All it is just a bunch of switches and sensors. You, as a human, need to be the one to make the final decision. This boiler is operating correctly, or this boiler is not operating correctly and needs to be shut down. And that is how we avoid making bad decisions, and that's how we avoid accidents. And that is why it is so important to be properly trained and have competency on boilers, low pressure steam boilers, high pressure steam boilers, on combustion and burners, even on hydronic boilers. As I previously mentioned, all sizes of boilers have some kind of danger to them. Just because it's a small hydronic boiler, you may only have a 2 million BTU boiler. if you get an improper combustion mixture inside that boiler and that boiler backfires, you're probably going to know, and you're probably going to hopefully not be in the boiler room. Will it cause major damage? Probably not, but it probably will ruin the boiler. And if anybody is in the boiler room, they'll probably have to go home and change their pants. But that is why we as boiler professionals need to be trained up, be aware, and put down our foot and say, no, this is unsafe. We are doing it by the book. Don't listen to outside pressures when it comes to boiler safety. There is nothing worth doing that it comes to bypassing boiler safety. It's not worth it. I don't care how many thousands or millions of dollars some corporation is supposedly losing by the boiler not running. If the boiler was essential, they would have more of them and they would make better decisions in maintenance. Yet, every single day, somebody is put in a hard decision of needing to make the boiler run when it is not in proper operating condition. Tubes are leaking, water's running out the fire side. No, the boiler's not going to just evaporate all the water. That leak will get worse. That tube could rupture. Now you have a big problem on your hands. You need to shut down the boiler. And with that, I'll wrap up this podcast. Thank you for listening. Please rate the podcast 5 stars. That really helps me. All 10 of my listeners right now, hopefully growing to 20 baby steps at a time. But like I said in previous podcasts, this podcast, I want to share information to help you learn. And it also helps me get better communicator, better talking, and to share information that is valuable to you. If you have any suggested topics or want to be on the podcast or have a recommended guest to be on the podcast, you can email me at eric.johnson@boilern.com. That's ERIC.JOHNSON @BOILEARN.com. Thank you for listening and stay wild.